Thank you. So now we go to frequency response of amplifiers. We are going to study about the high frequency analysis of amplifiers. So we in the high frequency response, we have lot of parameters like you have voltage gain, you have current gain. Some amplifiers they measure trans conductance. Can anybody say what is the expression for conductance? Conductance, conductance equal to conductance formula for conductance. Nobody else is there in the class. What is the formula for conductance? Resistance. What is the formula for trans conductance and trans resistance? The voltage gain means output voltage by input voltage. Current gain means output current by input current. Conductance means current by voltage. So output current by input voltage. Trans resistance means resistance equal to V by I. So it is output voltage by input current. So we can measure four parameters for any amplifier: voltage gain, current gain, trans conductance, and trans resistance. Voltage gain is going to be having no unit or expressed in decibels. Current gain, same thing. Trans conductance, the unit is ohm inverse. You draw a symbol like this, mho. You call it as ohm inverse, or you call it as mho, or you call it as Siemens. That is the unit of trans conductance. For trans resistance, the unit is going to be ohm. Okay, so for any amplifier, I can measure all these parameters as a function of frequency. So you can vary the frequency, and for each frequency, you can measure what is the gain. Specifically, these experiments only you will be doing it in the third semester lab. You will be finding out the frequency response of amplifiers. So you are going to plot gain versus frequency. Frequency will be along x-axis, gain will be along y-axis. And the gain is usually plotted in terms of decibels because decibels will accommodate larger values into smaller values. And frequency is plotted in terms of hertz in the logarithm scale. So you are going to vary from 1 hertz to 1 megahertz. So now drawing that in normal graph is not possible. So you are going to apply logarithm for your frequency, and then we are going to plot it on a semi-log graph. So semi-log graph la one axis will be in logarithm, one axis will be in normal graph. So the axis which is in logarithm, we are going to use it for frequency. The normal portion of your graph, I am going to be using it for gain. Okay, so normal graph, both the axes will be in the normal way. You have drawn the characteristics of Zener diode, common base, common emitter, adellame normal graph. But whenever you go for amplifiers, I cannot use normal graph because I cannot draw the complete frequency scale. So I will go for semi-log graph where I will be plotting x-axis in a logarithm scale which denotes your frequency, and y-axis will be your normal scale denoting your gain. So the main purpose is to determine the frequency response of amplifier and the high frequency mainly because of the capacitors. So high frequency, remember this capacitors will start playing differently in the high frequency. The capacitance effect will be predominantly seen in the high frequency. That is the reason why we go for analyzing an amplifier at high frequencies. From the frequency response, I can find the maximum gain, I can find the bandwidth, I can find the transfer function. So all these things are going to be after drawing your graph. After drawing the frequency response, I can measure all these parameters from the graph. Okay.